1, evaluate nth roots and use rational exponents. So a couple notes first. The definition, the nth root of a is written as a little n with the root and then an a. And n is the index of the radical. On your calculator, you can do an nth root as well. It's normally, our radical button is right here, right above x squared. But if you want an nth root instead, if you hit math and then arrow down, there's a cube root option. But then this one that's an x root, if you click that, it'll allow you to put in another number, like for your, it's using a number I had in there before, but it'll allow you to choose a number to put in there for the nth root. So like the cube root of 27, and it will produce that for you that way. So if you ever need that little trick for your calculator. All right, real nth roots of a. Let n be an integer, n greater than 1, and let a be a real number. And so we're going to have two columns here. The first one is n is an even integer. And then the other side, as you may guess, n is an odd integer. So if a, on the left side, if a is less than 0, there are no real nth roots. I'm going to stay on this side. If a is equal to 0, there is one real nth root. So like the nth root of 0 is equal to 0. Then if a is greater than 0, there are two real nth roots. Plus or minus the nth root of a is equal to plus or minus a to the 1 over n. Then for if n is an odd integer, a is less than 0, there is one real nth root. So the nth root of a is equal to a to the 1 over n. If a is equal to 0, there is one real nth root. So the nth root of 0 is still 0, obviously. And then if a is greater than 0, there's one real nth root. So the nth root of a is equal to a to the 1 over n. Then the last of the notes, I think, rational exponents. So this is like kind of the big thing I want to hit on in this, just to make sure that we're good with. But rational exponents, let a to the 1 over n be an nth root of a, and let m be a positive integer then a to the m over n is equal to a to the 1 over n raised to the m power, or in radical form can be written as the nth root of a raised to the m. If we had a to the negative m over n, the negative still, even with this, the negative exponent still flips it to the bottom, still put it where it ain't, make it positive. So 1 over a to the m over n is equal to 1 over a to the 1 over n raised to the m, or 1 over the nth root of a raised to the m, assuming a is not equal to 0, because now it's in the denominator. So in the first one, it could have been 0, because, you know, in the numerator, but not on the other ones. And all the normal rules of exponents still apply, even though they're now fractions. They're rational. So we're going to look at not a ton of examples, but just a few out of this section. It's a super fast and easy section. Actually, I'm going to save this, though, so I have a